Welcome, everyone, to Part 4 of our ISTQB mobile app testing series, in which we will take our CT-MAT exam readiness to the next level and boost our mobile app testing knowledge and understanding along the way. And for those who want extra preparation, you can always check our Udemy course, which contains an additional 6 exams with the same quality level of questions and explanations. Now it's time to take a look at question number 21. Let's do it. Your independent test team tests mobile apps for connectivity issues, providing detailed bug reports with reproducibility steps. Which of the following is the best approach? Great. Let's take a look at the available options to choose from. A. Crowd testing to bring a high number of test findings. B. Field testing to test networks in real-life scenarios. C. Using emulators to mimic various network conditions. D. Setting up a custom network to manipulate network conditions. All right, so the case here is a team that provides independent test services for other organizations. This team specializes in performing web connectivity testing, and the question challenges us to pick the most suitable approach for this team. Now, let's take a look at the 4 provided options to see which of them would match our understanding. Starting with option A, crowd testing. Crowd testing is not the best approach for testing mobile apps for connectivity issues. While it can bring a high number of test findings due to the large number of participants, it lacks the accuracy and precision required for connectivity testing. Additionally, the reproducibility of network conditions is critical in such tests, and crowd testing makes it difficult to control and replicate the exact same conditions. So, option A is not what we're looking for. Moving to option B, field testing. This one involves testing in real-life scenarios, which can provide valuable insights into how the app performs under various network conditions. However, it offers poor reproducibility because it's challenging to replicate the same test conditions consistently. Given that our team focuses on providing detailed bug reports with reproducibility steps, field testing is not the best option for us. Next, using simulators and emulators, that's option C. This one is also not the best option for us. Using simulators and emulators to mimic various network conditions can be beneficial, especially in the early stages of mobile app development. However, the results are of limited benefit for thorough connectivity testing. As an independent test team providing detailed bug reports, a more specialized approach is needed to ensure accurate and reproducible test results. Finally, we come face to face with option D, which should be the correct answer. Setting up a custom network to manipulate the network conditions are indeed the best approach. By using a custom private network, we can control various parameters such as the type of network, such as Wi-Fi, 3G, 4G, and 5G. Also, we can control the signal strength and bandwidth. This allows us to provide detailed bug reports with accurate reproducibility steps, ensuring that any connectivity issues can be consistently replicated and addressed. So, the best approach for your independent test team to test mobile apps for connectivity issues while providing detailed bug reports with reproducibility steps is option D, setting up a custom network to manipulate network conditions. This approach allows for precise control and replication of test conditions, ensuring accurate and reliable results. Very nice. Now, let's quickly encounter question number 22. The question says, as a software tester performing installability testing, which of the following methods is not relevant to downloading an Android mobile application? As usual, 4 options are provided to choose from, and they are A. Copying the files containing the app code to the install directory. B. Downloading and installing the application from the Google Play Store. C. Sending the APK file to the device via Bluetooth and then installing it. D. Using a data cable to install the app through Android App Installer from a PC. Great. So this question challenges us to find the only option that does not resemble how a software tester would install a mobile app in order to perform installability testing. Let's take a look at each option. For option A, copying the developer files into the install directory is not a standard method for downloading or installing an Android mobile application. As software testers, we need to use methods that mimic the actual user experience. This approach is more related to early development environments and not relevant for testing the installability of mobile apps. So, option A is a very strong contender to be the correct answer. Moving to option B, getting the app from the Google App Store over the air. This method is the galactic standard for downloading and installing an Android mobile application. The Google Play Store is the primary source for users to download apps, and testing the installation process through this method ensures that the app is accessible and functional for all users. Next, option C, transfer the APK file via Bluetooth and then install it. This is called sideloading. Sideloading is one of the established methods for installing Android applications. By sending the APK file via Bluetooth, data cables, or any other method, and then installing it, we can test the app's installability in scenarios where users obtain the app from sources other than the Google Play Store. Lastly, option D, using a data cable to install the app through Android App Installer from a PC. Also, an example of a valid method. This approach is often used by developers and testers to quickly install apps on devices for testing purposes, but it's also accessible to the public if they want to. In summary, the method that is not relevant to downloading an Android mobile application is option A, copying the files containing the app code to the install directory. This method is not used for standard app installation, unlike the other methods listed, which are common practices for installing Android apps. Enjoying the video so far? Hit that like button to let us know, and make sure you've subscribed to our channel One Run Academy on YouTube and follow us on LinkedIn. Now, let's encounter question 23. Which of the following options is the most valid for a mobile app tester performing different security test tasks? Ensuring temporary app data are removed if the app crashes. Getting the top 10 security vulnerabilities through L10N. Ensuring data stored in the remote server are encrypted. Verifying that the mobile device is secured with a PIN. Now, let's dive into the options and understand why each one is correct or not. Looking at option A, ensuring temporary app data are removed if the app crashes. First, let's understand what temporary data is all about. Temporary data includes cached information, session tokens, and other transient data that the app uses during its operation. Now, if this data is not properly deleted, it can become a vulnerability, as attackers might access it to gain unauthorized information. Therefore, we, as software testers, must ensure that temporary data is securely deleted when it is no longer needed or if the app crashes unexpectedly. This is a key part of mobile app security testing. So I think we can accept this conduct as a very strong contender to be the correct answer to this question. Anyway, let's move to option B, which says getting the top 10 security vulnerabilities through L10N. Surely, this one can be immediately recognized as an incorrect option. This is because a tester can get the top 10 mobile vulnerabilities from the OWASP organization, not L10N. OWASP stands for the Open Web Application Security Project, which is a well-known source for security vulnerabilities and best practices in web and mobile application security. Moving next to option C, ensuring data stored in the remote server are encrypted. This one can be a little bit deceiving. You see, as far as mobile application testing is concerned, remote data encryption is not within the scope of mobile app security testing. Mobile app security testing focuses on the encryption of locally stored data and ensuring the app transfers data securely. However, how this data is stored remotely is a concern of back-end security and database security. So this option is not correct. Lastly, Option D, verifying that the mobile device is secured with a PIN. Yes, securing a mobile device with a PIN is a good security practice. However, it is not relevant to mobile application testing. Mobile application testing actually focuses on the app's own security measures, not the general security settings of the device. So in summary, the most valid option for a mobile app tester performing different security test tasks is option A, ensuring temporary app data are removed if the app crashes. This task directly relates to mobile app security by preventing unauthorized access to transient data. Nice. Let's now shift our attention toward question number 24, which looks like an easy one. Which of the following is not a factor contributing to the performance of a mobile app? The options to choose from are A, backend and database architecture, B, algorithms used in mobile app code, C, the size of the mobile app itself, D, network speed or bandwidth. Perfect. Let's dive into this question together. And let's start by understanding the core of what we're trying to figure out. The question asks us to identify which factor does not contribute to the performance of a mobile app. When we talk about performance, we're considering anything that could affect how quickly or efficiently an app operates, from how it processes information to how it interacts with a server or the device itself. Understanding these elements is key to knowing what truly impacts performance and what might be less relevant. Now, let's break down the options one by one to determine which of these factors doesn't belong in the list. Starting with option A, backend servers and database structures are critical to how well a mobile app performs. If your server is slow or your database is poorly optimized, user requests will definitely take longer to process. This delay is reflected in the app's performance, even if the app code itself is efficient. So, backend and database architecture definitely affect app performance. So, option A is not the one we're looking for. Moving to option B, algorithms used in the code. This one is also a determining performance factor. You see, the algorithms implemented in the app's code play a significant role in performance to ensure the app runs smoothly. For instance, a poorly optimized algorithm can create unnecessary processing, causing the app to lag. Thus, the app's code and the algorithms it uses are crucial to its performance. Next, option C. We can see that this factor is the least related to the performance when it comes to a mobile app. The size of the app, which might include many assets like images, videos, or sound files, doesn't directly impact its operational performance. These assets are usually static and don't contribute to the speed or efficiency of the app's functionality. In some cases, having these assets already included can even reduce the need for downloading them during usage, potentially improving performance. So, I think option C is a great candidate to be the correct answer to this question. However, let's move on and see what the last option is all about. The last option, option D, claims that network speed is a contributing factor to the mobile app's performance, which is true. The speed and bandwidth of the network can have a significant effect on app performance, especially for apps that require constant communication with a server. A slower network means slower data transfer, which directly impacts how quickly the app can load content or respond to user actions. So I believe it's very obvious by now. While all the other factors listed have a direct impact on how a mobile app performs, option C, the size of the app itself, is the least relevant to its performance. And that makes option C the correct answer to this question. All right, question 25 is coming up. And I know some of you might be feeling a bit tired, but hey, we're at that halfway point. Too late to quit, too early to celebrate. So let's tackle it and keep things moving. You are evaluating the usability of a mobile app designed especially for retired employees so that they can update their monthly payments receiving accounts. To help you accomplish this task, You referred to a book that describes well-established characteristics of the font, type, size, and color suitable for elder people. Which of the following options most describe your activity? Very nice. Now let's take a look at the available options to choose from. A. Holding a usability lab. B. Using personas. C. Using heuristics. D. Performing test tours. Okay, so this question presents a scenario where you're evaluating the usability of a given mobile app specifically designed for retired employees. The app's purpose is to allow these users to update their monthly payment receiving accounts. To accomplish this task, you're referring to a book that provides well-established guidelines on font type, size, and color that are suitable for elderly users. This suggests that your focus is on ensuring the app is easy to read and navigate for people who may have poor eyesight due to age, considering the fact that the user group here is retired employees. Now that we understand the context, let's evaluate each of the options provided to determine which one most accurately describes the activity you're performing. Let's start with option A, usability labs. Usability labs involve gathering participants, typically representative of your target users, and observing how they interact with the app. The goal is to collect feedback directly from these users to identify any usability issues or areas for improvement. In this scenario, however, you're not working directly with users, but instead referring to a book for guidelines. Therefore, this option does not align with the activity described in the question. Moving to option B, personas. I'd also say no for that. Personas involve creating fictional characters that represent different user types who might use the app. By stepping into the shoes of these personas, you can better understand how different users might experience the app. In this case, you're not creating or using personas to empathize with your users. Instead, you're relying on a book of guidelines, which means this option is not the most accurate description of your activity. Next, option C, heuristics. So, in the context of mobile app testing, heuristics are established guidelines or best practices that help in evaluating the usability of an app. In this scenario, the book you referred to serves as a heuristic. It provides general rules of thumb that are particularly relevant to ensuring the app is accessible to elderly users. By applying these guidelines to assess the font characteristics, you are effectively using heuristics. Lastly, let's check option D, which we know is already not true. And that's easily concluded when we take a look at the definition of test tours. Test tours are a form of exploratory testing, where you navigate through the app to discover usability issues or areas for improvement on the fly. This method involves actively interacting with the app without predefined scenarios. However, in this situation, you're not exploring the app freely. Instead, you're specifically referencing a book to apply established guidelines. Therefore, this option does not accurately describe your activity. So, again, I think there's no doubt that option C is the correct answer to this question. Great. Now let's proceed to the next question, which I believe is number 26. This question states the following. Which of the following options is not an example of a tester conducting mobile app database testing? As usual, 4 options are provided. So let's read them together. Verifying industry standards, read-write speeds of the locally stored data. Ensure the required database type stated in project requirements is implemented correctly. Test for proper interoperability with other data owned by other apps on the same mobile device. Validate database sanity when trying to inject SQL code through input fields of the app. Very well. Let's start by breaking down the question to make sure we fully understand it. The scenario presented involves a tester conducting mobile app database testing. We need to identify which option does not represent a typical task in this context. Each option involves a different aspect of working with databases, so we'll analyze them one by one to determine their relevance to mobile app database testing. Starting with option A. This one does seem incorrect because it represents a task clearly relevant to mobile app database testing. Verifying the read and write speeds of locally stored data is a database performance-related task. It involves ensuring that the app's database operations meet industry standards, which is a critical part of assessing the app's performance and responsiveness. So, option A is not the answer we're looking for, since we are seeking an option that does not correlate directly to mobile app database testing. Now let's shift our focus to option B. This option seems like the correct answer because it is not an example of a tester conducting mobile app database testing. Instead, it's more aligned with design verification or system integration testing. Verifying that the correct database type has been implemented as specified in the project requirements is a task that ensures the system's architecture meets design expectations. Remember, mobile app database testing includes 3 subtasks: validation, integration, and performance. This option is none of them. So, we can think of option B as the correct answer, for now. Okay, let's quickly encounter option C, which does represent a task relevant to mobile app database testing. Interoperability testing involves checking whether the app's database can correctly interact with data from other apps on the device. This ensures that the app can access, share, and synchronize data across different databases, which is essential for maintaining data integrity and functionality. So, option C is not the correct answer, matching our expectations. Moving to the last option, which we already expect, is not correct. And indeed, this option is not correct because it also represents a valid database testing task. Validating database sanity by testing for SQL injection is a critical part of database security testing. It ensures that the app's database is secure and resilient against common security threats, which is a crucial aspect of maintaining data security and integrity. So again, option B is the one that is not an example of mobile app database testing and is confirmed as the correct answer to this question. Great. Let's take a look at question number 27, which says, a tester is using a VPN to simulate different locations on a mobile app. He then assesses how accurately the app displays date formats, time formats, number separators, and currencies based on the location. What type of test is the tester mostly performing? The options to choose from are A. Usability testing, B. Networking testing, C. Exploratory testing, D. Globalization testing. Awesome! This question describes a situation where a tester uses a VPN, which is an app that can spoof other apps that the user is somewhere else on the globe to simulate different geographic locations. After simulating these locations, the tester checks how well the app adapts to various regional settings, such as how dates, times, numbers, and currencies are displayed. Now let's walk through the options to determine which type of test the tester is most likely performing. Starting with option A, usability testing, I would say no. The tester in the question focuses on how the app adapts to different regional settings, not on how easy or intuitive it is to use. This task is not about the app's usability, but rather its adaptation to regional differences. So, this option is not our hunt. Moving to option B, networking. I truthfully don't think so, as the tester in this scenario isn't concerned with how the app performs over the network. Instead, the focus is on how the app adjusts its settings based on the simulated location, which is unrelated to network evaluation. Next, option C, exploratory testing, which is not correct. Although exploratory testing could uncover issues with regional settings, this isn't the primary focus of the task described. The tester is not randomly exploring the app, but is systematically verifying its behavior under specific simulated conditions, which confirms that he's not conducting exploratory testing. Lastly, option D, globalization. This one is the most reasonable answer. The tester is precisely performing globalization testing. By simulating different locations using a VPN and checking how the app handles regional settings, the tester is ensuring the app can properly adapt to various geographic regions. So I believe that option D is the correct answer to this question. Now, let's encounter question number 28, which says, which of the following is considered a disadvantage when it comes to mobile app field testing? Very well, let's take a look at the available options. A, the extensive utilization of simulators and emulators. B, the need for extensive planning prior to testing. C, it requires testers with high technical skills. D, the lack of user perspective test results. Great! The focus of this question is on understanding which factor is considered a disadvantage when it comes to mobile app field testing. Field testing is all about taking the app into real-world environments to see how it performs under actual conditions that real users would encounter. And since field testing is primarily conducted in real-world conditions, the use of simulators and emulators is not central to this type of testing. Therefore, option A does not describe a disadvantage related to field testing. Now let's encounter option B, the need for extensive planning. This one seems like a valid disadvantage of field testing. Can you guess why? Actually, this is because field testing involves setting up various scenarios in different real-world environments, which requires careful preparation so that all possible variables, locations, devices, and conditions are accounted for. This is extremely important to enhance the reproducibility of field testing. Moving to option C, which we already know is incorrect. Field testing is focused on evaluating the app's performance or behavior in real-world conditions. While technical knowledge can be helpful, the emphasis in field testing is typically more on how the app functions in actual user environments, rather than requiring advanced technical skills such as coding or automation. Lastly, option D is immediately recognized as incorrect. This is because one of the strengths of field testing is that it is designed to replicate the actual user experience, and the entire purpose of field testing is to ensure the app performs well under conditions that users will actually encounter. So again, option B is considered a disadvantage because planning for field testing involves significant effort to account for all possible real-world conditions and variables, which makes the process more resource-intensive and complex than other forms of testing. Next, question number 29 says, your organization has just granted the required approvals for its mobile app released on the Apple App Store. Now, you are tasked to perform some post-release tests. Which of the following activities is the most related to your current task? A. Verify that the app can be downloaded and installed from the App Store. B. Measure the app's performance and compare it to the documented requirements. C. Check the compliance of the UI designs with the platform's standards and guidelines. D. Review the app's code against best coding standards and practices. Very well. Let's analyze this question together. The scenario is that your app has received the green light from the App Store to be released. Your task is to perform the post-release tests. But what does this post-release testing mean? Well, post-release tests are carried out after the app has gone live on the App Store. These tests help ensure that the app works as expected when end users download, install, and interact with it in the real world. From this point, we can start analyzing the options together. Starting with option A, we can see that this option directly relates to post-release testing. This is because in post-release testing, the first thing a tester should check is whether the app can be successfully downloaded and installed from the App Store or not. It simulates the real user experience after release, making this the most relevant activity for post-release testing. Now, let's confirm that the remaining options are irrelevant to post-release testing to solidify our rationale. Option B is easily recognized as incorrect. Performance testing should have been completed way before the app was released to the App Store. Measuring performance and comparing it to requirements isn't the primary focus at this stage. Moving to option C. Again, this activity should have been performed during store approval testing, not during post-release testing. By the time the app is live, compliance issues should already have been identified, addressed, and resolved. Finally, option D is without a doubt an incorrect option. Code reviews are some of the very earliest SDLC activities and are not relevant to post-release testing. So confirmed. The correct answer is option A. Verify that the app can be downloaded and installed from the App Store. This is the most relevant post-release activity because it simulates the user experience and ensures that there are no issues with downloading or installing the app after it has been released. And finally, we reach the last question in this video, which is question number 30. So let's take a quick look at this one. And the question says, I Sliced Up Fun contains 2 U letters. Which of the following options is not related to any U in this mnemonic? A. Verify the mobile app provides the correct functionality. B. Ensure coverage of the most common use cases of the app. C. Test the mobile app's UI button placement across devices. D. Validate the app is easy to understand by the end user. Very well. So, to be able to answer this question, we must remember what each letter U means in the I Sliced Up Fun mnemonic. Do you recall them? Yes. One stands for usability, and the other one stands for user scenarios. From this point, I think things will get pretty much easy. Now, all we need to do is to check options A, B, C, and D and decide which option is the one that does not relate to usability or user scenarios. So let's do this now. Option A. Verify the mobile app provides the correct functionality. This one sounds like functional testing to me. So I think this one is the one we're looking for. But let's review the other options to confirm. Moving to option B, ensure coverage of the most common use cases of the app. This one sounds like it's describing the user scenarios. That's very nice. Now, option C, test the mobile app's UI button placement across devices. I think we can relate this to usability, at least one way or another. Lastly, option D, validate the app is easy to understand by the end user. This one is perfectly aligned with the app's usability. So, the final conclusion is that option A is the only one that does not relate to usability or user scenarios, while the remaining options do. Therefore, it's safe to say that option A is the correct answer to this question. Very well. With question number 30 answered, I think we've reached the end of this video. So please show your support by giving this one a thumbs up, and feel free to post your questions in the comments section below. I will try to answer them as quickly as possible. In the next video, we will encounter questions from number 31 to 40, which should be the last one in this series. So, stay tuned for that.